In this video, we're going to be talking about the discriminant, and the discriminant is super useful in the real world because it allows people to quickly find information about the roots, that is the solutions, to a quadratic equation and the shape of a quadratic graph. And we looked at quadratic graphs in the previous video. So make sure you're confident with solving quadratics and quadratic graphs before checking out this video. Now, by the end of this video, you should be able to understand what is meant by the discriminant and understand how many roots a quadratic function has by looking at the discriminant. Okay? So, the first thing we need to know before we get into this is that if we square any number, we're always going to get a number greater than 0. So, for example, if we have 3 squared, we can hardly see that. Let me just change the colour here. If we have 3 squared, that's going to give us 9. But if we also have -3 squared, that's always going to give us 9 as well. So it's always going to be greater than 0. Whether we have a positive or negative number, if we square that number, it's going to be greater than 0. Okay? Now, because of this, if you try to find the square root of a number, for instance, let's say we tried to find the square root of -x, the answer cannot be a real number and your calculator will show an error. In other words, you obviously cannot find the square root of a negative number if no number can be squared to produce that negative number. So if we square a number, we're never going to get -x or negative anything, because squaring a number, whether it's positive or negative, will always give us a positive result. And this information is really useful when looking at quadratic equations. For instance, let's look at the quadratic formula, which is used to find the roots and solutions to a quadratic equation. So the quadratic formula looks a little bit like this. So if we want to find the solutions or the root of a quadratic equation, we can find the solutions as such by plugging minus b plus or minus the square root of b squared minus 4ac over 2 times a. And these b's, a's and c's come from the fact that our quadratic equation is going to look a little bit like this. So the a's go where the a's are, the b go where the b is, the c goes where the c is, for example. Okay, so if the number under the square root sign in the quadratic equation, so this number under here, is negative, then x cannot be a real number. Okay, so there'll be no real solutions. But if the number under the square root sign in the quadratic formula is 0, then both of our solutions of x will be the same. Now, for the quadratic function fx equals ax squared plus bx plus c, the following expression, b squared minus 4ac, so this bit under the square root, this is called the discriminant. Okay? And the value of the discriminant shows how many roots we have to this function here. Okay, so let's have a little look. If we have b squared minus 4ac, okay, so our discriminant, and the result of that, so whatever number that is, that produces, is greater than 0, then we're going to have 2 distinct roots, okay, 2 solutions. If we have b squared minus 4ac equals 0, then we're going to have 1 repeated root. So it would just be 2 roots which are exactly the same, 1 repeated root. And then finally, if we have b squared minus 4ac, and that is less than 0, then that's simply going to give us no roots at all, okay? There's going to be no solutions to that. Now, the other thing, by using this information here, we can use the discriminant to check the shape of the quadratic graph, okay? So, for instance, let's have a look at some graphs quickly. So we've got our discriminants down here still. And if we had a graph that is shaped like this, and it's sort of is this shape, so we've got a positive quadratic graph here. Now, when the discriminant is greater than 0, like here, the quadratic graph will intercept the x-axis, which is obviously this horizontal one here. This is our y-axis. It's going to intercept our x-axis at two distinct points, okay? Because we have two roots. So when b squared minus 4ac is greater than 0, then we know that the graph is going to intercept the x-axis at two distinct points. If we had a graph that instead looked a little bit like this, so we've got, again, our y-axis, our x-axis, but this time the graph does this, okay? Now, we can see that this only has one root, okay? It only touches the x-axis at one particular point. So here, b squared minus 4ac is going to be equal to 0. So if you see that b squared minus 4ac, the discriminant, is equal to 0, then we know we're going to get a graph that looks a little bit like this. Also, it could look the other way around. It could also just touch like that. Similarly, with this one, it could have gone up and down like that, okay? So positive or negative, it does the same thing, crosses the x-axis twice here, and it doesn't cross at all when the discriminant is equal to 0. And then finally, when the discriminant is less than 0, the quadratic graph won't intercept the x-axis at all. So it will look, it could be up here somewhere, it could be, down here somewhere. It won't actually cross this x-axis at all, okay? There's no crossing points. So when the discriminant is less than 0, there are no roots or solutions. So let's have a little look at an example. Let's get rid of all this information and let's do a question. So let's find the values of k, okay, for which f of x, our function, is equal to x squared plus kx plus 9, and for the values of x for which this has equal roots, okay? So we're looking for the value which has equal roots. Right, from the quadratic function here expressed as ax squared plus bx plus c, we know that a is equal to 1, b is equal to k, okay, and c is equal to 9. So let's identify a, b, and c, and you should really always do this when you're trying to deal with the discriminant, okay? Now, we know the quadratic function will have equal roots when the discriminant is equal to 0. So we know that this equal roots means b squared minus 4ac equals 0. That means it has equal roots. So we simply want to substitute a, b, and c over here into the discriminant to get an equation with one unknown, which is k. So let's do that now. So b squared, so that's going to be k squared. And we've got negative 4, okay? And we want times a, 4ac, so negative 4 times 1 times c. And that's going to be equal to 0, okay? So we just plugged in our a, b, and c into our discriminant over here. And 4 times 1 times 9 is 36. So we're going to have k squared minus 36 equals 0. And then we're going to add 36 to both sides. It's going to give us k squared equals 36. And then we can solve this then to find the values of values of k by taking the square root, okay? So the square root of both sides will give us k equals plus or minus 6, okay? Because negative 6 times negative 6 can give us 36, and so can positive 6 multiplied by positive 6. Okay, so that is our solutions, the range of values for x for which, or the values of for k, sorry, which has equal roots. Now let's look at one final example before finishing off this video. Okay, so what if we are told to find the range of values of k, again we want a range of values this time, for which x squared plus 4x plus k equals 0 has two solutions, two distinct solutions or two distinct roots, okay? Now, from the quadratic function here, x squared plus 4x plus k, we can see that a is equal to 1. So let's write this out now. A equals 1, b equals 4, and c equals k. Okay, perfect. Now we know that this quadratic function will have two distinct roots or solutions when the discriminant is greater than 0. So we're looking for a situation where b squared minus 4ac is greater than 0, because that's going to give us two solutions. Okay. Now we want to simply substitute a, b, and c again into the discriminant to get an equation with one unknown k. Now, also note that as this statement involves an inequality, this symbol here, our answer will also be an inequality. Okay. So first of all, let's plug these values in. We've got b squared, so we've got 4 squared, minus 4 times a, which is 1, times c, which is k. And that's going to be greater than 0. Okay, don't forget the inequality sign. Now 4 times 1 times k is 4k, and 4 squared is 4 times 4, which equals 16. So this is going to be 16 minus 4k is greater than 0. And simply we're going to add 4k to both sides to give us 16 is greater than 4k. And we can divide both sides by 4. So we're going to divide this by 4, we're going to divide this by 4. 16 divided by 4 is going to give us 4, and 4 divided by 4 is 1, so that's just going to give us k. And it's always good to try and put your unknown on the left-hand side, so we can just switch this round to say that k is less than 4. Okay. So in other words, for any value of k less than 4, the equation will have two distinct solutions. Okay, so that is the end of this video, and I think that is now the end of talking about quadratics. So if you have any questions at all about this particular video, then please leave a comment below and I'll get straight back to you. If you enjoyed the video, make sure you give it a thumbs up and subscribe to my channel. Thank you very much for watching.